Bismillahir Rahmanir Rahim. Good morning, guys. This is our 14th episode. Still, we are in chapter 5. And as you know, chapter 5 has 8 topics. All of them are for the supplement and only one for the core, which is the state that concentration can be measured in gram decimal, cubic, and mole decimal cubic. So this is the only part where the core share chapter 5. I wouldn't like to talk too much about this because we already know that, and however, it is an important chapter. You have to work hard with it, and you are going to be a pro. Follow the way that I try to explain things and to solve problems, and you will reach and become a hero in chapter 5 topics. Let us go. In our today's class, we are going or we will study actually the percentage yield and the percentage purity of a substance, compound, element, whatever. And by this, we are going to add to our knowledge something that is very nice, very interesting. A reaction may not always yield the total amount of product predicted or theoretically predicted by equation. In any, we always explain or explore any type of reaction in terms of chemical equations. And if we calculate our amounts inside this chemical equation, it's going to be the theoretical prediction or the predicted amounts, whether it is the in amount or the out amount, the reactants amount or the products amounts. So this is not true all the time, depending on different things. Some of these amounts may be lost due to different cases, and let us take some of them. The reaction may not be totally complete. That means, for a reason, this reaction is stopped for a reason. Why? Maybe due to the presence of limiting reactants or any other things. For a reason, it is stopped. So there is no longer a reaction. So still we have some of our reactants are not reacting weren't reacting to each other. Error may be made in weighing the reactants or products. We always, as we make the recipes, we always weigh those reactants, 2 grams of this with 3 grams of this. Sometimes there may be some mistakes in having the correct way for the reactant due to personal error or even instrumental errors. Material may be lost lost in carrying out the reactions, or in transferring, or doing anything for the product. For example, during filtration, when you filter the some of the reactants, you may lose some of the amount you added to. Also, presence of impurities. You have 10 grams of copper, but actually it is not completely copper. There is something else, not 100% copper. So there is some other metals or some other components in it, and this makes it impure. And this always happens in the contaminated crude reactants. And for this reason, we study percentage yield and percentage purity. Let us move forward. So if this is the case, what is the percentage yield and what is the percentage purity? The definition of each of them is like the following. Percentage yield equal or means a measure of the actual yield of the reaction when carried out experimentally compared to the theoretical yield calculated from the equation. The equation is going to give you an amount as if you consume all the reactants. You consume them all, and all of them are pure. You don't make any mistake on weighing. There is no problem in filtration or transporting or separation of the reactant. Nothing. And this is very theoretical. It can't happen in real life. Real life has different things. So you cannot be sure that if you have 2 grams of element, for example, A, you are going to use those 2 grams completely without losing any of it. And for this reason, we have this equation in order to determine the percentage yield, which actually is the actual yield over, which equal to the actual yield over the predicted or theoretical yield multiplied by 100. This is always the maximum, always over than this. You cannot put 2 grams of substance and then you receive from this substance 3 grams from the other side. No. So this is always higher than this one. And also we have another term which is called percentage purity, which means a measure of purity, of the purity of a product from a reaction carried out experimentally. And it is the percentage mass of the predicted of pure product over the mass of impure product multiplied by 100. By this we can get the percentage purity, and by this equation we can get the yield purity, the percentage yield. Now we are going to take some examples for this in order to determine the purity and also to determine the percentage yield. Please follow me for each example, and I am sure that you are going to master this and become a pro in it. Let us go for our first example, which says heating 12.4 grams of copper 2 carbonate in crucible produce only 7 grams of copper 2 oxide. What was percentage yield of copper oxide? So let us just dismantle this example. There is a heating of 12 grams of copper 2 carbonate. Second, the product is only 7 gram of copper oxide. So we need to know the percentage yield of copper oxide. How much copper oxide percent wise? So step number one is to write a proper and a balanced equation for such reaction. It says Cu, which is copper, C, which is carbon, O, which is oxygen, so this is copper carbonate, and the valency of both the group of carbonate and copper is 2, so they neglect each other, so it is CuCO3, and when we heat it, this is the sign of heat, then the remaining is going to be copper oxide and carbon dioxide. And by this, the equation is okay and balanced. If you are sure that your equation is balanced, then determine the number of the mole ratio. So 1 mole here, and the reactant side gives me 1 mole of copper oxide, 2 oxide, and also 1 mole of carbon dioxide. I'm not interested in carbon dioxide because the example doesn't say anything about carbon dioxide, so I'm going to neglect it. And then I should determine the relative molecular mass of the reactant and the product under investigation, which are copper to carbonate and copper to sulfate, respectively. And then after I find that, I'm going to express them in gram. And you see, I also bring to the table the from the periodic table each one of these copper, carbon, oxygen, because they are not here. They are not in the they are not given by the examiner. So I'm going to look for them in the periodic table and see what should I do for that. Now, by determining this, we have 64 relative atomic mass of copper, and it is only one atom, so it is only 64. Also, one atom of carbon, which has 12 atomic mass, and then 3 multiplied by 16 because we have three three atoms of oxygen. Then after that, we are going to find that this is equal to 124, and for the copper oxide, it's gonna be 80. So I'm gonna have two numbers. For copper carbonate, it is 124, 124 grams, and for the copper oxide, it is 80 grams. Now, in those first 3 steps, I determine the proper equation, I determine the mole ratio, and also I determine the molecular mass for each of them. Then we are going to see in the second scene what we are going to do with this information that we calculate. Now our example is continued, and we would like now to come out with the actual and expected yields in order to compare them together. So step 4 is to determine the expected and actual yields. So based on the information that I have from the equation, if I heat, when heating 124 gram of copper 2 carbonate, it should have produced 80 gram of copper 2 carbonate oxide. So based on the information which I get from the first scene using the equation, when heating 124 grams of copper 2 carbonate, it should have produced 80 grams of copper 2 oxide. This is from the equation. Now, therefore, 12.4 gram, which is given, of copper carbonate should produce 12.4 multiplied by 80 over 124, which equal to 8 grams. I want you to explain to me from where I get 12.4 multiplied by 80 over 124, from where I get this equation. Okay, or this side of equation. This equal to 8 grams of 8 grams of copper sulfate copper oxide. Thus, the expected theoretical yield is 80. Why? Because from where I get this point, I get it from here. From here I get this information from the calculation of the equation. 124 grams of copper carbonate is going to give me 1 mole of copper sulfate, which is 80 gram of copper 2 oxide. Sorry, I always say sulfate, but this is oxide. Okay, this is from where I get it, from the equation. Based on this, I'm going to calculate, if I don't have 124 gram, I have only 12 gram, 12.4 gram, how much this is going to give me. There is a lot of ways to do that, but I choose this way. 12.4 gram of copper 2 carbonate should produce 12, this one, multiplied by 80 over 124. And this means 80 gram. Okay, according to the equation calculation, if I have only 12.4 gram of copper 2 carbonate, this amount should produce 8 grams of copper 2 oxide. Okay? Okay. So the expected theoretical yield from the equation is 8 gram. However, the example say that the actual yield is 7 gram. So now I have the actual which is given by the problem or the example, and the 8 which I bring it out from the information in the example, and the same thing, the information of the I come out with the equation. Now, because I have those two, to determine the last step is to determine the percentage yield. So the percentage is equal actual yield, which is this is the actual yield over the predicted theoretical, which is this one. So it is 7 over 8 multiplied by 100 equal to 87.5%. Okay, very simple. Just go one by one and just compensate. You will be the bro. Now we have the second example. It is also example that we can use the same strategy to fulfill it. And simply it says student reacts 4.5 gram of aluminum powder with chlorine gas. 17.8 gram of aluminum chloride are produced. Calculate the percentage yield of this reaction. So in this one, we are going to deal with another substance or another compound, an element, actually two elements react to each other. One of them is solid, the other one is gas, and we have to deal with that. Okay, so the first one is to write proper and balanced equation of such reaction, which is aluminum plus 2 aluminum plus 3 chlorine molecule gives us 2 molecules of aluminum chloride. Aluminum here is solid, which is powder. Chlorine is a gas, and aluminum chloride is also solid. Or you can say salt. Okay, now the second is to determine the mole ratio, which is 2 mole from aluminum with 3 moles of chlorine, give us 2 mole of aluminum chloride. Step 3 is to determine the molecular mass and also the molecular mass in addition to the other mass, which is the atomic mass of aluminum. And from the periodic table, I got them, and it is up there. The one for the relative atomic mass of the is 27, and of the molecular mass of the, or the formula mass of the aluminum chloride is 27 plus 3 multiplied by 35, which equal to 133.5. So when I express them in gram, I put those together, which is 27 gram to 133.5 grams. This is simply what I have to do, what we have to do together in order to, in the first step, to bring about how much moles are there and also how much one are there. Putting in consideration that 2 moles of aluminum gives 2 mole of aluminum chloride. So those 2 moles and those 2 moles, we can also say 1 mole of aluminum gives 1 mole of aluminum chloride just by divided by 2. This is a relative proportion. Now, moving towards step 4, which is responsible for come out with the expected and actual yield, doing the same thing when 27 gram of aluminum reacts with chlorine it should gives 133.5 gram of aluminum chloride. Therefore, 4.5 gram of aluminum should produce 4.5 multiplied by 133.5 over 27 equal 22.25 grams of aluminum chloride. So, the expected theoretical yield of aluminum chloride is 22.25 grams, while the actual yield, which is given from the given in the example, it is only the actual yield. Now we use this formula in order to bring about the percentage yield. So the percentage yield equal actual yield over the predicted or theoretical yield multiplied by 100, which is 17.8 over 22.25 multiplied by 100, and this is 80%. This is the way that I always use in order to determine the percentage yield. Sometimes we need to measure or determine the purity of an element, a compound, anything, because we need to use it in a special way. For example, copper is always used to make the wires of the electrical charge. You see those types of wires. You see those wires. And it is very important to choose the maximum purity, or at least the suitable purity for the purpose. So it is advantageous to know the percentage purity or to determine it. And now we would like to take one example that tell us how we can get this purity. Let us go for our example, which says an initial crude sample of copper, is prepared industrially and then tested for purity. They made it and then tested for purity. A sample of 10.15 gram of crude copper is analyzed by various methods, shown to contain 9.95 gram of copper, with the remaining mass being made of other metals. I'm not interested for the other metals. I need to know exactly how much purity, how much pure this one. Now, the first step is to determine the correct stoichiometric equation for this. And this equation is percentage purity equal mass of pure product over the mass of impure product multiplied by 100. Step 2 is to compensate to determine the purity of the copper sample. Now, percentage purity is like this, and then we just go for what we have here is 9995, which is the copper, the amount of copper present in this crude copper is 9.95 over the actual one, which is the mass of impure product, which is 10.15 multiplied by 100, and this is 98.03%. And we always keep at least 2 digits, so it should be from 4 correct or figures or significant figures. So it is 98 point oh point 03%, and this is very nice type of copper, that very pure. Yeah. So by this we come out with the percentage purity and how we can deal with it. This session have been ended now. We know now two main terminologies, the percentage yield and the percentage purity. Both of them are very important. We deal with three examples. We make it, we solve it step by step. Do not drop any step at this stage, but by trying to solve many problems from these types, you are going to find a way to deal with all things. You can even you can even solve it in your mind. You don't need a paper, but for the time being, try to follow the steps one by one. You can reach it. I believe in you. I understand your situation, and I can guarantee that if you follow those steps, you are going to be pro in osteochrometry, and you deserve that. You deserve that. Your family deserves that, and I think you are going to do a lot of good jobs in the future. Have a good day. Bye bye, and I wish you good luck.